Hello everyone and welcome to the second video talking about math.random and casting. Last time we did several examples of ranges of decimal numbers. We started off with the simple original range of 0 to 1, not including 1, and that's what math.random gives us. And then we tried out some basic arithmetic, multiplying and adding numbers to change the lower bound and the upper bound, or the smallest number possible and the largest number possible in our range. This time we're going to continue, but we're going to aim to only get whole numbers in our range. So if I say 0 to 5, we might get the numbers 0, 1, 2, 3, or 4. We can do not inclusive, and then we'll try inclusive. So let's go ahead and start. We'll start off with a simple range. So we'll say target range is going to be, and we'll start off with 0 to 5. And we'll say not inclusive, but we'll say we want integer values. So we'll make a new variable this time. We'll call it random. And how can we do this? What do we now have? What tool do we have that allow us to convert or get only whole numbers, even though math.random generates decimal numbers? So let's try getting the decimal equivalent, and then maybe we can easily convert to the whole number equivalent. So math.random times 5. So 0 to 5 is our goal. So let's try the lower bound. When math.random is 0, we would get 0 times 0.0 times 5 would be 0.0. That's the lower bound. And then if it was 0.99 times 5 would be 4.99. That would be right below 5 as decimal numbers, and that would work. But now we want a whole number, and of course we also made an integer variable, so we have to have a whole number answer. So what can we do? What's one approach to converting a double into a whole number? And the answer is to cast. So if we want to convert to an int, we'll put, oops, I didn't mean to select the whole thing. We will put an int in parentheses. Now we have to ask ourselves, is this the correct way? And remember, the precedence that we established up at the top was we said that we do parentheses, function evaluations, unary operators, and then casting. So we're going to evaluate a function and get an answer, then we're going to cast, and then we're going to do arithmetic. So in this formula, we recognize math.random is a function, int is a cast, and then the multiplication. So unfortunately, this is not going to work. Let's try it. If we did our lower bound, we would get 0.0 from random. It would be cast to an int, which would be 0, multiplied by 5, which would be 0. And then we get 0. That seems to be a good lower bound. Now, what would our upper bound be? It should be 4, because a number that's not including 5, that the last number that's a whole number, not including 5, is 4. If random gave us 0.99 repeating and we cast to an int, what is 0.99 repeating as an int? It's 0 because casting causes truncation. So we would get 0 again, and then we'd multiply by 5 and we'd get 0. So we would always get 0 no matter what. And so instead, we make a small adjustment and we say, let's do the multiplication first and then truncate. And so let's validate it one more time. The lower bound would be 0. 0 times 5 would be 0. 0 cast to an int would be 0. Our lower bound is still the same. Our upper bound hopefully should be 4. 0.9 repeating times 5 is 4.9 repeating. 4.9 repeating cast to an int would be 4, because 0.9 repeating is truncated or just eliminated. We're left with 4. So now if we run this, if we print it, and we put random, we can try and see what the results will be. 4, we got 4, let's try it again. We got 3, we run it again. We got 1, let's run it one other time. We got 4 again, 3 again, 0. So we got 0, but we will not see 5 as a possibility. That's what we aimed for, not inclusive of 5. There's 2, and there's 1. We've seen every number except 5, and we can keep running this. And again, running it a bunch of times is not a proof that it's correct, but I'm fairly confident that we've done our job. So let's try doing this again, but with a different range. So 0 to 5 is a pretty good range. Let's try something that says, and we'll just immediately start with something better. Let's do something like 7 to 31, not inclusive, and we want it to be integer values. The same thing is going to apply. So we're going to make sure that at some point there's a cast, and it probably will be the last thing. And just like before, if we're going to adjust the upper bound, we're going to multiply by some number. And if we're going to adjust the lower bound, we're going to add or subtract. And by doing so, we should also readjust the upper bound. So the multiplication is maybe not obvious. So you can pause the video, try to do it yourself, and then we'll do this now in a moment. So we'll say that our answer is the cast of an int, and then math.random. And notice I put it in a big set of parentheses because just like before, the cast must be the last thing to occur. And so we'll multiply by 24, and then we will add 7. So if you're not sure, let's go ahead and try it. And I'll go ahead and copy and print it as well, just so we can see it afterwards. Lower bound. Random gives us 0. 0 times 24 is 0. Or 0.0 because it is a decimal. 0.0 plus 7 is 7.0. 7.0 cast to an int is 7. So we get our lower bound. Upper bound. I think I made a mistake. Maybe it should be 25. Let's see. So math.random 0.99 times 24 will be 23.9. Oh, no, it is correct. So yeah, 0.99 repeating times 24 is 23.99 repeating. 23.99 repeating plus 7 would be 30.99 repeating. 30 cast to an int is 30. 30.99 repeating cast to an int is 30. So we would get from 7 to 30, not including 31. So that's the exact range that we want. We run it. We can try it a few times. I got 21. I got 11. I got 20. 28. 16, and so on. So we can run this a bunch of times, and potentially the idea is that we will never see anything below 7. We will see 7. We will not see 31. We'll see 30 maybe, but not 31. So let's go ahead and try to make a general formula for integers where the lower bound and upper bound are both positive numbers. So a general formula for lower to upper, not inclusive, where lower and upper are both greater than 0. And lower is less than upper. We're going to make those two assumptions about our formula, that lower and upper are both positive numbers, and lower is always a smaller number than upper. So given that, what can our formula be? We'll say random is equal to. And now let's go ahead and make some variables first. And I'm going to make them and give them values just so we can actually test it, but the reality is the values are not important. It's more about the variables because we can plug in any positive numbers that follow those two rules. So we would say something like int lower, and I'll go ahead and just put a small number like 5, int upper is equal to, let's say, 100. And so now what is our formula? The same thing is going to apply. Our cast will be the last thing. We will do our multiplication. And so what did we do here? How did I get 24, right? I said what? 31 minus 7 is 24. So it was upper minus lower. So times upper minus lower. And notice I do need the parentheses because the subtraction happened first. If I don't put parentheses, then it'll be random times upper subtracting lower. That's not what we want. So we want upper minus lower as one number multiplied against random. And then afterwards we add, what was 7? It was the lower, so plus lower. And there's our formula. Oops, excuse me. And the idea is that as long as upper and lower follow those two rules, both positive, and both lower and bigger being smaller than upper, then this works for any random range. I can put 0 to 1,000,000. As long as they're integers, it will work. So 14, we get 30, 7, 20. Let's see if we can get a bigger number, hopefully. 13, that's still kind of low. Oh, again, I'm so wrong. I didn't print it. That's kind of important. I should probably print the number. That might be a little bit smarter. So let's try that. So 7, we got 7. Let's see if we can get a bigger number. 77, okay, that's within range. 36 is well within range. 62, and so on. And so let's try something bigger. Let's do something like from 120 to 2020. So a much larger range. And obviously the larger the range, the less likely we are to see duplicates, at least near each other. It's possible, but it's a lot less likely. And there it is. And we can see that we can get anything in that range. And so this is very convenient for positive to positive numbers. Now I'll say that if we want a more exotic range, for example, from a negative lower bound to a positive upper bound, we can actually still manage it with a general formula. So if we tried doing something, I'm going to go ahead and copy and paste this. So I want a general formula from lower to upper, where lower, and so now here where let's correct this part, where lower is negative or is less than 0, and upper is 0, and which would imply that lower is less than upper, so I don't have to write it, right? So we could put a negative in front of lower just to make it clear, but that's what we're saying, is that lower is a negative number, upper is a positive number, and the reality is it's the same formula, there's only one difference. And so before we do this, let's try an example. Let's do something like random, let's say lower equals -5, upper equals +5. So let's just leave this formula and see if it's correct. And then if it's correct, then we're good to go. If it's not, then maybe we have to make an adjustment. And I think that we might be okay, but let's check. And if we're not, we can make an adjustment. So let's do the lower bound. Random is 0. So 0 times anything, so I'm not going to even bother doing the math, is 0. 0 plus -5, which is my lower, is -5. The lower bound seems correct, right? So again, my range here, I didn't put it, but let's go ahead and put our range. We said from -5 to 5, not including 5. Oops. And let's go ahead and test the upper bound. So here we go. So now it's 0.99 repeating times, and let's go ahead and do this. Upper is 5 minus -5, minus -5. So what's 5 minus -5? That's the same as saying 5 plus 5. That gives us 10, plus lower, which is -5. So 10 minus 5 is 5. So 0.9 times 0.99 repeating times +5 is 4.99 repeating. 4.99 repeating is cast to an int is 4 flat, which is the correct answer because we were not including 5. So the formula works both for positive and negative lower and then positive upper bounds. And so this is very convenient, but the question remains, does it work for negative to negative numbers? And the answer is unfortunately not, and it's a little more complicated. And we're also missing another idea. We haven't been inclusive, but could we make these inclusive? And the answer is actually, that's the easy part. For positive to positive and negative to positive, making it inclusive is very, very simple, right? So this is good, but let's try one last time. Let's say random equal to, and my goal is going to be the same thing, but inclusive of 5. What will change here? There's only one small correction we need to make. We need to include 5. So I'm going to just copy this and we'll say, and again, I'll give you a moment. If you pause the video, you can try to figure it on your own, and we'll go from there. So the result, all we have to do is add 1 to the subtraction. So let's just prove it. So let's do the lower bound. 0 times anything is 0. 0 plus -5 is -5. The lower bound is still easy and correct. The upper bound. So here we go. 0.9 repeating times 5 minus -5 is 10. Plus 1 is 11. 11 plus -5 is 6. 6 times 0.9 repeating is 5.9 repeating. 5.9 repeating cast to an int is 5. So there it is. Our upper bound is 5. So this is correct. So the only adjustment, and this works for up here as well, so both from lower to upper, as long as upper is positive and lower can be either negative or positive, if we add 1, we're inclusive. If we don't add 1, we're not inclusive. And so that's not bad. It's very flexible. Now, I'm not going to try to do negative to negative. That's an exercise that I'll leave to you. I will say that it might be a little more challenging to come up with a generic formula. But if you want to try that, that's a great thing to do. And if you can spot one, that would be fantastic. And in the future, maybe we'll have an opportunity to write more functionality that allows us to kind of have both things happen. We can merge them into one in a smart strategy with some decision making. When we get to that point, it would be really nice to make our own random function. And that would be really cool to do. And so we can use this right now, what we've learned so far, and then if you try doing negative to negative, you could potentially blend that in. So I'm going to stop the video here, and we will continue next time with a new topic. I'll see you in the next video.